Welcome. Today we're diving into the Python Collections module. Consider it your toolkit for advanced data structures, designed to make everyday programming tasks easier and more efficient. In this module, we'll explore specialized data structures that go beyond the basics of lists and dictionaries. We will be covering named tuples, deque, counter, default dictionary, and ordered dictionary. Let's explore the benefits of using Python's Collections module. This module provides specialized container data types, offering high-performance alternatives to Python's built-in data structures. These alternatives are optimized for specific use cases. By using the Collections module, you save time with pre-built implementations, and it is important to note that the Collections module is part of Python's standard library, so no additional installation is required. The Collections module provides specialized data structures that offer high-performance and optimized solutions for various programming needs. Let's explore named tuples. A named tuple is a factory function for creating tuple subclasses. You can access fields by name instead of index. Named tuples allow for self-documenting code with field names, and they are immutable just like regular tuples. They also offer a memory-efficient data structure. Now let's look at some basic usage. First, import named tuple from the Collections module. Then create a named tuple type called point, with fields x and y. After that, create an instance p with values 10 and 20. Now access the values by name, p.x and p.y. This will output 10 and 20. You can also access them like a regular tuple, p at index 0 and p at index 1, which will also output 10 and 20. Now let's look at some advanced usages of named tuples. You can use space-separated strings. Here we create a person named tuple with the fields name, age, and job. You can also use defaults. Here we create an employee named tuple with the fields name, ID, and department, where the default for the last field department is HR. Now create an employee Alice with the ID 1001. The department will automatically be assigned as HR. You can also use useful methods. Here we create a student named tuple with the fields name, age, and grade. Then we create a student named Bob, who is 21 years old, and has a grade of A. You can convert this to a dictionary, using s._ as dictionary, which will output a dictionary with the keys name, age, and grade, and their corresponding values. You can also create a new instance with changes. Here we create a new student S2 by replacing the grade of S with B. Now let's talk about deque. Deque is a double-ended queue. It is optimized for fast appends and pops from both ends, with big O of 1 complexity for append or pop operations. It is also thread-safe and memory-efficient. It is useful for queues and sliding windows. Deques can also be bounded with a fixed maximum length. Now let's look at some basic usage. First, import deque from the Collections module. Then create a new deque with the values 1, 2, and 3. To add to the right side, or the end, use d.append for. This will result in the deque containing 1, 2, 3, and 4. To add to the left side, or the beginning, use d.append left 0. This will result in the deque containing 0, 1, 2, 3, and 4. To remove from the right side, use d.pop, which returns 4, and the deque becomes 0, 1, 2, and 3. To remove from the left side, use d.pop left, which returns 0, and the deque becomes 1, 2, and 3. Let's explore some advanced usages of deques. You can use rotation and extending. First, import deque from the Collections module. Then create a deque with the values 1, 2, 3, 4, and 5. To rotate to the right, use d.rotate2. This will move the last two elements to the front, resulting in the deque containing 4, 5, 1, 2, and 3. To rotate to the left, use d.rotate-2. This will move the first two elements to the end, resulting in the deque containing 1, 2, 3, 4, and 5. To extend the right side, use d.extend 6 and 7. This will add 6 and 7 to the end of the deque, resulting in the deque containing 1, 2, 3, 4, 5, 6, and 7. To extend the left side, use d.extend left 0 and -1. This will add -1 and 0 to the beginning of the deque, resulting in the deque containing -1, 0, 1, 2, 3, 4, 5, 6, and 7. Deques can also be bounded. Create a bounded deque with max length equals 3. When adding elements with d.append 1, the deque becomes 1. With d.append 2, the deque becomes 1 and 2. With d.append 3, the deque becomes 1, 2, and 3. When adding a fourth element with d.append 4, the leftmost element is dropped, resulting in the deque containing 2, 3, and 4. This is perfect for sliding windows. Now let's discuss counters. A counter is a dictionary subclass for counting hashable objects. Elements are stored as dictionary keys and counts are stored as dictionary values. Missing items have a count of 0, so there is no key error. Counters are perfect for frequency analysis and support arithmetic operations such as addition, subtraction, intersection, and union. Let's look at some basic usage. First, import counter from the collections module. You can create a counter from an iterable, such as a string. Here we create a counter from the string abracadabra. This results in a counter where A has a count of 5, B has a count of 2, R has a count of 2, C has a count of 1, and D has a count of 1. You can also create a counter from a mapping. Here we create a counter with A equals 5, B equals 2, and C equals 1. To get the count of an item, use C at index A, which returns 5. If you try to get the count of a missing item such as C at index Z, it will return 0 instead of throwing a key error. To update counters, use C.update with the iterable, such as the string AAA, which will add the counts to the counter. Now let's look at some advanced methods for counters. We can use common methods. First, import counter from the collections module. Then create a counter from the string abracadabra. To get the most common elements, use C.mostcommon3. This returns a list of the 3 most common elements and their counts. To get all the elements with counts, use list C.elements. This will return a list of all the elements in the counter, with each element repeated according to its count. To remove entries with 0 or negative counts, use C+ equals counter. Now let's look at mathematical operations. Create counter 1 with A equals 3, B equals 1, and C equals 1. Then create counter 2 with A equals 1, B equals 2, and D equals 1. To add the counts or create a union, use C1 plus C2. This results in a counter with A equals 4, B equals 3, C equals 1, and D equals 1. To subtract the counts, use C1 minus C2. This results in a counter with A equals 2, and C equals 1. To get the intersection or the minimum of the counts, use C1 and C2. This results in a counter with A equals 1, and B equals 1. Let's explore default dictionaries. A default dictionary is a dictionary subclass with default values. It never raises a key error. It automatically creates items with a default factory. The factory function is called for missing keys. This simplifies nested data structures and is useful for grouping and counting. Now let's look at some basic usage. First, import default dictionary from the collections module. To create an integer default which starts at 0, use d equals default dictionary int. If you try to increment a key that doesn't exist, such as d at index A plus equals 1, it will not throw a key error. Instead, it creates A with 0 first and then increments it to 1. Printing d shows a default dictionary with int, and A equals 1. To create a list default, use d equals default dictionary list. If you try to append to a key that doesn't exist, such as d at index fruits.append apple, it will not throw a key error. Instead, it will create fruits with an empty list and then append apple to it. Doing d at index fruits.append banana results in printing d to show a default dictionary with list, and fruits equals a list of apple and banana. Let's explore ordered dictionaries. An ordered dictionary is a dictionary that remembers the insertion order. It preserves the order of keys added and has special methods for reordering. Equality tests are order sensitive. Since Python 3.7 plus, regular dictionaries also maintain insertion order, but ordered dictionaries still have specialized methods. Now let's look at some basic usage. First, import ordered dictionary from the collections module. To create an ordered dictionary, create a variable OD and assign it to ordered dictionary. Then add keys in a specific order, such as first equals 1, second equals 2, and third equals 3. To move an item to the end, use OD.move to end first. This results in the ordered dictionary second, 2, third, 3, and first 1. To pop the first item using the first in, first out method, use OD.popItem last equals false. This returns second, 2, and removes it from the dictionary. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.